Hey all, Circle and Security back in my lab today, and I want to talk to you about mDNS, or Multicast DNS. Now, this is an alternative to the regular DNS protocol that does not need an authoritative name server to work. Particularly, it uses just the link local network and blasts out a request saying, hey, is anyone out there that can respond to this name? Give you a quick example. We'll open up the File Explorer, and I'm going to do // file share. And what we're going to see is mDNS start firing off both IPv4 and IPv6 and say, hey, is anyone out there that can respond for file share.local? You'll notice it tacked on this file or this .local portion on its own, and that's a Windows feature. This is cool. This can be used for a couple of different use cases, primarily things like, hey, I don't have an authoritative DNS server because it broke, or we're not set one up yet, or this is a dev environment. It can also be used things like Chromecast, which we'll get into later. Ultimately, though, there's one big glaring problem here. We are trusting what's ever on the network to correctly respond and say, yes, they are fileshare.local, and they actually are. We have no way to verify if they are actually what they say they are. So let's actually see this in action. I'm going to switch over here to my Debian box. And what I'm going to do is I'm just going to launch the very prolific tool Responder. This tool was made years and years, I think coming up on a decade ago now. So it's very much in the public domain. You can find it on GitHub. I'll try to drop a link in the description. And we're just going to say, hey, on my primary interface, ENS18, I want you to listen for any mDNS events. Now, it's also going to listen for other things like LLMNR and Netbios. Those are much easier to resolve than mDNS is, so we're not going to worry about them too much right now. So, all right, that's running. Let me switch back to my Windows box, and let's clear this out for Wireshark and try this again. Let's say // file share. And we do see a bunch of responses fire again, but this time something is responding to these requests. Looks like 10.0.0.4 is responding and saying, hey, it's file share. Fantastic. Now, we'll notice something weird though. We're getting asked for credentials for now. Well, maybe I realize that this doesn't normally happen, so I'm not going to do anything. Does that mean I'm safe? No. In fact, if we come over back here to Responder, we can see that those mDNS is fired and a couple of LLMNRs as well. And yet we captured the hash for Sir Glenn, my user account, multiple times. And that's because when let me switch back to the Windows here. When we made that request and we got that response, it said, okay, that's great. Could you go ahead and authenticate to me over SMB so I can share the files with you? Windows automatically in the background said, hey, I'm already logged in. I've already got some stored network credentials I can use. I don't need to bother the user with asking them for their credentials. If I do, I'm going to be doing it like 6 times an hour at least. User doesn't need that stress. I'm just going to authenticate to this service for them. Very kind of Windows. Unfortunately, the attacker didn't even need me to input my credentials now to capture them. Now, those are NTLM v2. That's not the clear text, right? So that's not something, in fact, we can actually showcase that pretty well here. Let me swap back. We'll do this one more time, and I'm going to actually input some credentials here, right? We're going to say test user, which doesn't actually exist, and we're going to say tester, right? Access is denied. If we pop back over here, we can see this is an NTLM v2 with SSP hash. So this is not the clear text. However, this is still crackable offline if the user is using anything even remotely weak. We're not just talking about 8-9 character passwords here. We're talking about anything that is guessable based on human psychology. And I've got in a lab or in an environment where I've got a good hash cracking machine, or in an environment where I'm willing to upload the victim's password hashes to the cloud, we're talking about trillions or at least high billions of password guesses within the time frame of a usual password reset, which can be anywhere from a month to 3 months on average. not taking into the fact that the recommendations are starting to change from NIST to not rotating passwords very often. Whole different subject I don't want to get into here, but suffice to say, we have some time to try those cracks, to try to crack this offline, which means that a 15, 16 character password is not safe if they're using banned lyrics or Bible verses or just duplicated words with an exclamation point at the end. There's so many ways that users of all shapes and sizes fail at creating passwords securely that this gives us a really, really good chance of cracking it. It gets worse. Because we've captured the MTLMv2 hash, we can also relay that hash to any service that does not verify its authenticity or where it came from. This means that things by default, such as SMB and LDAP, can be relayed to, as well as your Active Directory certificate services. Those are just the common things in a Windows environment. They are by far not exhaustive. That means that if you've not taken the time to do that extra security work and lock those down already, I can now relay this test user or the Sir Glenn account to the DC, authenticate without ever seeing that clear text password, and start to take actions as that user. That could be creating my own account, which could get me flagged in an environment, but it could also be running LDAP queries. It could also be modifying accounts that the Sir Glenn account has permission to. That might not be many, but it might be enough to go ahead and get me authentication, start letting me roll through. The LDAP queries themselves for something like LDAP domain dump could be a massive pool of things like all your usernames, all your comments in AAD, your groups, your permissions when you made them. So I now know who the domain admins are and all other kinds of juicy information like password policy, the trust in your network. The list of things that you can query from LDAP goes on, and is an incredibly huge win if you're just getting into an environment. And in fact, if you go to something like MITRE, they do have a list of threat actors that actively use things like LDAP dump, domain dump. It is not just a theoretical attack that we only see in pen tests. Attackers are doing it too. Okay, so that is kind of rough. What can we do about it, right? We've identified a problem. How can we stop this from occurring? Well, mDNS is a bit of an interesting protocol in that it actually has some real use cases, unlike some of its other ones that we just saw issue with, like LLMNR and Netbios, which are also things we want to shut down for the same reasons. If we go into a PowerShell here and do netstat-ano find string :5353, we're going to see that a process at 1268 is the one binding these. We can open up Task Manager, right click and make sure your PID is shown, and then we can scroll down until we find 1268. 1268, boop boop, DNS client. Okay, so that's the Windows built-in DNS client. We can't just exit this process like if it was a standalone thing, otherwise we'd kill our DNS, and that's not good. But it's a Windows process, so we have GPOs. We can apply those GPOs, we can shut mDNS down, and this will, like 1268 will still be a process running, but it won't bind port 5353. Fantastic. There's another problem. Microsoft Chrome, or Google Chrome, not Microsoft Chrome. Let's do fileshare2.local. We do have to add the .local this time. We're getting prompted for password again. Sure enough, mDNS fired for fileshare2.local. We go back over to our screen here, and okay, we aren't automatically getting that authentication though. Fantastic. This is a big step in the right direction, but there's a lot of users that are not going to walk away from this. Some even that are technical savvy if they're not thinking about it. So let's do test and see what that happens. Well, we have the NTLMv2 hash again, noticeably even without the -SSP. Okay, so that's fine. Google Chrome will just listen to our GPOs, right? No. Let's run that find string again. We'll actually notice that 9028 is another process binding up the mDNS protocol again, the port specifically. So we go down here and yep, there's Google Chrome binding port 5353 alongside the Windows built-in DNS. It's brought its own mDNS stack. Well, this is fun. If you're confused on why this can happen, UDP is different than TCP in that you can actually have multiple processes binding those ports. There's some nuance in how it all works that's beyond the scope of this video, but ultimately both of them can do it, can listen, can send. So that's a problem. GPOs won't apply to Chrome. We could go into Chrome settings and disable it. That's a pain in the butt. What about Edge? Does Edge do the same thing now? We open this up. Okay, we still see just the same ones. Maybe this won't. Let's go edge.local. Shoot. Okay, well, is it bringing its own? It is. It has now brought its own processes as well. We can see them at 424. It has triggered the moment it needed it. It then went and bound the port. Edge might listen to your GPOs, but we're starting to see a trend here. On Windows, ultimately any application can bring its own mDNS stack, and they don't have to listen to your GPOs or registry edits. That means that even if you do kill it off at the DNS client level through the GPO that's easy to find, easy to use, you still might be vulnerable to this. Less likely, but plugins, default operations, all of those can naturally fire off without the user having to mistype into and add the .localit, which is very unlikely. But also things like Teams do it automatically, and we've seen a ton of DNS requests from them that aren't active anymore, which then trigger mDNS lookups. And that's just the common applications. You can imagine that there's a ton of these tiny applications that you never hear in the public, but that you have to run in an organization for X reason, that ultimately are going to start firing off mDNS and not listening to your GPOs. So that sucks. This is also not the only tool we can use this with. There are even better tools like Pretender that do an absolutely fantastic job and lets you really drill into which host you want to respond to. So some of the security tools will do like a blast of random 8-character string, and if something responds to that, it'll flag it and give an alert to the blue team. Great victory. Unfortunately, there are good tools that you can easily spot that and ignore. There is a couple of tools out there that do a better job of this by mimicking something in your actual domain. Unfortunately, that's still just not enough. A sophisticated attacker can absolutely look at that and go, hey, that's suspicious. That's not what I would expect to see being blasted every 30 seconds on the second. I'm going to ignore that one and just go after everything else. So, does that mean we're out of options? No. There is something we can do, and that is the Windows firewall. So, let's go ahead and get that up and running. We will skip ahead because I'm going to have to run this as administrator. Okay, so here we are back, and now we have the Windows firewall up. Before we make this policy, I want to briefly touch on something else. You may have noticed that there is this PTR Google Cast request showing up in my mDNS traffic. This is where mDNS gets a little more complicated. There are legitimate use cases for mDNS, and that is really, you'll probably think of it as your Chromecast. You can use mDNS for service discovery. And some of the really cool things that I've seen used with this are like projectors or conference room equipment that doesn't need to be plugged in directly and uses mDNS to go find it. Except we don't want mDNS on the network because it is a legitimate security threat. In theory, there is a way with a sophisticated firewall to go through and say, hey, do not allow A record lookups, but do allow things like PTR lookups and everything else needed for service discovery. This is a topic I'd like to dive in deeper and get really solid solutions going without fancy firewalls. Unfortunately, at the moment, the only answer I have is fancy firewalls that can detect the A record versus the PTR record. If you have a good solution that does not require tens of thousands of dollars, let me know in the comments below. For now, though, we will lose this functionality with the solution I'm about to offer up. If that is a deal breaker, you may need to allow specific users or groups or configure your network in such a way that when you go into the conference room, on that network, you can access mDNS, whether you have to hardline in with Ethernet or whether that one wireless access point is the only one you can use. These aren't necessarily good solutions, but they're the ones I have at the moment. If that's not a problem for you, though, which I think there are many, many people out there that it won't be, you can block mDNS at either your network firewall level, if you've got enough of those and all traffic is going through them, or you can simply, through GPO, block them at the Windows Defender firewall level. So we're going to say inbound rules, new rule, and I'm going to go by port UDP 5353, block the connection, everything, and we're just going to call this the mDNS block. I suggest you use a more descriptive name if you're doing this in a corporate environment. All right, that is in. That is looking good. Enabled, yes. Okay, I think we're good there. Let's go ahead and go to outbound rules as well and create the same thing. Obviously, this will look a little different for you if you're doing this through GPO, but the process and theme is the same. We want to say UDP port 5353, block the connection on everything. And okay, now we still need a restart, so let's go ahead and do that real quick. We are going to restart this computer so that these rules will get will go into effect. Just to verify here, let's do one we haven't done. / subscribe. And yeah, those are still going out just fine. Let's go ahead and restart, and I'll see you back here when that is done. Okay, so we are back on the computer here. I'm opening up the Wireshark again, getting our mDNS set up, and firewall rules are now in place. Let's go ahead and test them. We're going to do / like the video, and we still got prompted, but you'll notice mDNS is not coming through. Okay, so that firewall rule worked, but there's more work to do. This is going back to the LLMNR and Netbios. They are actually triggered by Windows at the same time as mDNS. So as an added bonus, let's fix that as well. We can do that pretty easily. I'm going to do this from the machine by group policy. You would obviously do this from your DC as some type of group policy template or wherever you modify those. So what we're looking for here is the turn off multicast name resolution. You'll see this mentions LLMNR specifically. So we're going to come in here. We're going to enable. This is turn off, so we need it enabled. Hit apply and OK. And once again, this is going to require a restart of the machine. So in theory, you should do them both at the same time. Okay, so here we are back again after another restart. We're going to set up our mDNS capture again. And we are going to open up the file share. One last time, like and subscribe if you have not. To my completely inaccurate spelling. And we still get a response. Uh-oh. Why do we get a response? Because of Netbios. So we've disabled mDNS, we've disabled LLMNR, but we have not disabled Netbios. Why? Well, Netbios is completely separate, even still, from those other fixes. So back in the firewall, we're now going to make another rule specifically to handle Netbios. This is going to be another port. This is going to be UDP 137. And once again, we're going to block it on everything. And once again, also on the outbound rules, we're going to do the same thing. UDP 137. Block the connection, everything. Netbios. So now we've got a Netbios and an mDNS block, and we've got the LLMNR GPO setting applied. Let's go ahead and restart the system one more time, and we should see no more exploitable peer-based traffic. Okay, here we are back on the device again. Let's go ahead and try some peer-based name resolution. We will try just the file share again. And is it running? Doesn't seem to be doing anything. And we get that network error, no pop-up for our credentials. And just to go ahead and prove that we are still running that, let's hop back over here to this VM. And we're going to cancel that and rerun this. Okay, so now we are listening again. Let's hop back over to that Windows one more time. Like and subscribe if you like this kind of content. Don't mind my misspellings here. And no response. We swap back over to the responder and nothing is being hit at all. Absolutely fantastic. So that is how you fix mDNS as well as a couple of its alternative peer-based resolution protocols. Now, again, we have really locked this down. A couple of small tidbits here right at the end. I have heard that you only need to block inbound mDNS. I prefer to do both unless there is a requirement for the outbound. This is just a little bit stricter, a little bit more controlling. Additionally, you could just disable the inbound and outbound rules already enabled in Windows Firewall rather than making new ones. I prefer the new ones. Your policies and decisions may differ there. Either should be fine, either disabling the allowance or creating a new rule that blocks it. Just make sure your priorities are correct when assigning those rules. Netbios can be handled in other ways. There is supposed to be the GPO coming, and if you go search online, you will find many scripts that help you block or turn off Netbios as it starts. I believe there's a service that gets spun up at the startup, and you can disable that service, and a PowerShell script in the startup folder that runs as system can do that for you. I don't love it, but it's an option for you, and certainly one that I've seen many people use with GPOs. Just make sure it's not readable and writable by all users. And LLMNR we could have blocked by firewall as well, but the GPO for that one works and is readily available. I have not seen any issues with that. So ultimately, that is primarily mDNS and its peer-based alternatives. Really strong thing to secure your environments with. This also causes a lot of traffic in an AD environment, so this might also take some stress off your firewalls and other network devices if those are feeling some strain. Really hope you all enjoyed this content. I will be back more with soon. Please do let me know in the comments below if you have other options, if you have other things that I missed about mDNS that you'd love to see covered, or even just general to help the channel out. Really appreciate you, and I will see you next time.